We're going to go ahead and look at trigonometric functions, sine, cosine, tangent, and the three reciprocal functions of those. Now, we're going to look at it for the most part today only from the form of a right triangle trigonometry. So we're going to be using Sohcahtoa, which is an easy way to remember that sine deals with opposite hypotenuse, and that's listed here in black. Cosine is adjacent over hypotenuse, and you see that down here listed in black. And toa is tangent over adjacent, and you see that listed here in black. Now, Sohcahtoa only works with the acute angles of a right triangle. It does not work with the right angle. So if this happens to be our angle right here, A, then our opposite is over here, other side of the triangle. Adjacent means it's got to be next to your angle. And then hypotenuse is always opposite your right angle. If this were to happen to be your angle you were dealing with, well then your opposite is the other side of your triangle, adjacent is your side that's next to your angle, your leg, and then your hypotenuse is still here. Now, when we're looking at sine, sine is the reciprocal of cosecant, or cosecant's reciprocal of sine. Tangent and cotangent are reciprocals of each other, and you see that here. We also have cosine and secant, or secant and cosine are reciprocals of each other. Now, cotangent, secant, and cosecant may be new functions for you, but just remember that they're going to be dealing with those reciprocal functions. So here we want to find our 6 trigonometric functions for this triangle. Well, first of all, I need to figure out what my missing side is. I'm calling it y. Being a right triangle, I could go 5 squared plus y squared equals my hypotenuse squared using the Pythagorean theorem. So I get 25 plus y squared equals 144, so subtract 25 from both sides, and I'm going to get the square root of 119. It's actually plus or minus, but in the context of our picture, we're going with length, so it's only the positive root. Now you want to think of Sohcahtoa. Sine is opposite of my angle is my root over my hypotenuse, which is the 12. So its reciprocal function then is cosecant. Notice it begins with an S, its reciprocal begins with a C. So I got to flip that fraction upside down. And then we'd want to go ahead and multiply by a special form of 1 of the square root of 119 over the square root of 119 so that we could simplify this. And then we would end up getting 12 square root of 119 over 119. Cosine is adjacent, which is our 5, because that's next to our angle over our hypotenuse. So secant, notice it begins with an S, goes to the reciprocal that begins with a C, is the reciprocal. So we got to flip that upside down. And then we have tangent. Tangent is opposite, which is our root 119 over our adjacent of 5. And then our cotangent is the reciprocal of tangent. So I just have to flip that upside down. And then once again, you'd want to multiply by root 19 over 119 over root 119. So we would get 5 square root of 119 over 119. So here we have a right triangle with legs being 1. Notice it's an isosceles right triangle, so 2 sides are the same, so 2 angles have to be the same, so these are both 45-degree angles. Now you could remember how sides of an isosceles right triangle are related from geometry, or you could do the Pythagorean theorem. 1 squared plus 1 squared equals our hypotenuse squared, which I'm calling C. So 1 plus 1 is 2, so we get C to be the square root of 2. So this is the square root of 2. Thinking of Sohcahtoa, we can use either angle here for our 45 because we're going to get the same answers. So if I do sine, which is opposite of 1 over my hypotenuse, then multiply the top and bottom by root 2 over root 2 to get the root out of the bottom, we would get this. Now I need to do the cosecant. Notice it begins with the S, so its reciprocal begins with C. I could flip this one upside down, but that would put my root in the bottom. I'm going to choose to flip this one upside down so I don't have to deal with that root in the bottom. Now I'm going to do cosine. Cosine, here's my angle, is adjacent of 1 over my hypotenuse. And then I'll multiply top and bottom by root 2 over root 2 to get the root out of the bottom. Also, I need to do its reciprocal function, so I'm going to flip this one here upside down so I don't have a root in the bottom. And then I'll deal with tangent, which is opposite of 1 over adjacent, which is 1, which is 1. And when I do my reciprocal of cotangent of 45, it's also 1. So now I'm going to go ahead and do my 30, 60, 90 right triangle. This is how the sides are related, and that goes back to geometry for your special right triangle of a 30, 60, 90. When we're dealing with 30, this is going to be our angle. 1 would be the opposite, root 3 would be our adjacent, and 2 would still be our hypotenuse. So when we do sine of 30, opposite of 1 over hypotenuse of 2, we get this. So its reciprocal then would be 2. Cosine would be adjacent of root 3 over our hypotenuse of 2. So we flip that upside down for our reciprocal function, and then we'd have to rationalize that, and we get this. Then we have our tangent, which would be using Sohcahtoa. Tangent is opposite of 30, which is 1 over our adjacent, which is root 3. Then we'd want to multiply top and bottom both by root 3 over root 3 to get the root out of the bottom. And then when we're looking at the reciprocal function, I'm going to choose to flip the first fraction so I don't have a root in the bottom. When I'm looking at my 60-degree ones down here, I'm going to go ahead and let 60 be up here. So that means my opposite would be the root 3, my adjacent would be the 1, and 2 would still be my hypotenuse. So my sine would be my root 3 over 2. Flip it upside down for my reciprocal function. Rationalize the denominator, and I get this. Cosine would be my adjacent of 1 over my hypotenuse. So its reciprocal then would be 2. Tangent would be my opposite of root 3 over my adjacent, which is 1. Flip that upside down, rationalize it, and I get this. On the last two slides, we dealt with the sine, cosine, tangent, plus its reciprocals, but the sine, cosine, and tangent of 30, 45, and 60. You need to have those memorized. So you need to know each one of these 3 trig functions for each one of these 3 angles. So now we're going to go ahead and explore the idea of the Pythagorean theorem identity. You know your Pythagorean theorem in general is leg squared plus leg squared equals your hypotenuse squared. So if this is our adjacent, or our angle, this would be our adjacent side, this would be opposite. So we could go adjacent side squared plus opposite side squared equals 1 squared, and that's what we have here. But note, if we were doing the sine of our angle, sine would be our opposite over our hypotenuse. So it'd be opposite over 1. So in other words, sine is our opposite. If we were doing the cosine of our angle using Sohcahtoa, it would be adjacent over our hypotenuse, or adjacent over 1. And then putting it over 1 doesn't change it. So in other words, I could come along and rewrite this. Instead of writing adjacent, I could write cosine. Instead of writing opposite, I could write what my sine is. When I do that, I end up with this statement here. Now, it technically means this, but it's very common to write it like this. So what we have down here with the squareds in a slightly different spot really means this. So just be aware of that. So that's your first main Pythagorean theorem, identity. And yes, you will need to have that memorized. So suppose we take that first main Pythagorean theorem, identity, and we modify it and divide all 3 parts by cosine squared. So cosine squared over cosine squared would be 1. Sine squared over cosine squared, well, sine over cosine is tangent, they're both squared, so we get tangent squared. Here we have the reciprocal of a cosine squared. So the reciprocal of cosine, you know, is secant, so this would be a secant squared. Or suppose we take our Pythagorean theorem identity, our original one, and then we divide everything by sine squared, and we'll get a third Pythagorean theorem identity. So if we divide all three parts by sine squared, so over here we have 1 over sine. We know that that's cosecant. Because it's squared, it'd be cosecant squared. Sine squared over sine squared, it would be 1. Cosine over sine is cotangent, because sine over cosine, as we talked about over here, is tangent. Here we have it flipped upside down, so it's cotangent. They're being squared, so it's cotangent squared. So here we have 2 more Pythagorean theorem identities to go with the one from the prior page. You need to make sure you have all 3 memorized. Now, remember, tangent of theta is sine theta over cosine theta. It's not sine over cosine with 1 theta afterwards. Similarly, for cotangent is cosine theta over sine theta, not cosine over sine with a theta afterwards. Now we're going to look at one of our important definitions. This one and one more coming here are going to be really, really helpful for you. So here we have an angle. Our angle's in standard position, so that means its vertex is at the origin, initial side is in the positive x-axis, and our angle is rotating and going to the point of x, y. In other words, if we draw ourselves a triangle, we'll go x to the right, and we'll go y up. By the way, when you are drawing yourself a triangle, you always go to your point and you always make a right angle to the x-axis, always to the x-axis. Then, if you're looking for the length of your hypotenuse, which is r, it's defined to be as the positive square root of x squared plus y squared. Now, depending upon where you are in your coordinate plane, x and y could be negative. But according to our definition for r is always positive. Remember that. Now, we could, being a right triangle, use Sohcahtoa. Here's our angle. Sine would be opposite of the y over r, and that's what we have here. We could do Sohcahtoa. Here's our angle, here's our adjacent of x over r, which we have here. And we could do tangent, which would be our opposite of y over our adjacent of x, which is here. Now it says x can't be equal to 0 because remember you can never divide by 0. And then we have the reciprocal of sine is cosecant, so you take and flip your fraction upside down. We have the y can't be equal to 0 because you don't want y to be 0 because you can't divide by 0. Cosine, you do its reciprocal, you flip it upside down. Tangent, you do its reciprocal, you get cotangent is x over y. So if it's a right triangle, you could use Sohcahtoa, you could use this definition. Sometimes this definition is really helpful, and other times you can do it either with Sohcahtoa or this definition. So what's the domain of sine and cosine? Well, it's all real numbers. Because r is always positive, it's never equal to 0. However, because tangent and secant here, they both have issues when x is 0. Well, your angle for x being 0, if we would draw an angle in, would start here and go straight up. So that would be at 90 degrees or at 270 degrees. So if we go here, we're going to have issues with these two, all real numbers, except when we're at 90 or 180. So top of the circle plus half a revolution to get down to, I said 180, 270. So top of the circle plus 180 to get down to the bottom, and keep doing any multiple of 180. Or if you were dealing with radians, top of the circle is pi over 2, and adding a half a revolution is adding any multiple of pi. Now going back here, we would have issues when we're dealing with cotangent and with cosecant, the two cos, whenever the bottom is 0, and that's when your y is 0. So y is 0 here at 0, at pi, or 180 degrees, and then at 2 pi, or 180, or 360 degrees. So pretty much we're going to having issues at any half a revolution of our circle. So it's going to be all real numbers except any half a revolution of our circle. Whether you're dealing with radians, that would be pi n, if degrees, it's 180 n. So let's go ahead and find x and y here. We have an angle, we have its opposite side. If I want to go ahead and find x, which is my hypotenuse, I'd be dealing with opposite and hypotenuse, so I'm going to be dealing with sine. So I'll go the sine of my angle equals my opposite over my hypotenuse. Sine of 60 you're supposed to have memorized, which is root 3 over 2, equals what we had over there on the other side. Then we could cross multiply and solve it for x. And then in this case, we would get, if you did cross multiply and divide, you get this. But then you'd want to get the root out of the bottom, so there'd be a root 3 over a root 3, which is a 6 root 3 over a 3, which you could simplify your 6 and your 3 in front, and that's how you get your 2 root 3. Now, you could use the Pythagorean Theorem when you know two sides to find your missing side, but I encourage you to always go back to your original given information. Because if you would have made a mistake on finding this and used that to find y, it would throw y off. So if you go back to your original given information, you have this, your opposite, and you're looking for adjacent, thinking of Sohcahtoa, that is tangent. So you go tangent of 60, which you're supposed to have memorized, which is root 3. We have a fraction equaling a fraction. You can cross multiply and then get y on one side by itself by dividing by root 3. Then you got to get the root out of the bottom, and you get this.